Hi guys, it's Mr. Jenkins here. I'm going to go ahead and get right to the 8-3 notes for Algebra 2. This is about rational functions and how to graph them. Anyways, I'm just going to kind of fly right through it, and you can pause and rewind and rewatch as needed. Some of you guys may just, the notes may be enough, and so if so, you don't have to watch these videos. These are just here in case you need them, okay? So the learning target says I can graph rational functions and state its asymptotes, holes, intercepts, domain, and range. So those are the kinds of things we're going to be focusing on today. In our first example, right here, given the function y equals x plus 3 over x minus 4, we want to find the vertical asymptotes. So on page 1 of our notes, there's this informational part, and it says right here to do with vertical asymptotes, f of x has a vertical asymptote whenever b of x equals 0. So that just means b of x is the denominator, so where the denominator is not 0. So we're just focusing on the x minus 4 part. So since our denominator is x minus 4, we just set that equal to 0, and then solve for x, giving us x equals 4. And remember, when you have a line in the form x equals a number, that is a vertical line, so that would be our vertical asymptote. And remember, an asymptote, well, we'll get more into that once we start to graph. Okay, so the next one wants us to find the horizontal asymptote, and sorry, skip down one. It wants us to find the vertical asymptotes and holes of the graph of the rational function. So again, if we're just looking at vertical asymptotes, we're just focused on the denominator. In this case, though, we need to first simplify because we have an x minus 2 factor up here and an x minus 2 factor down there. So as we know, that just cancels out to be 1. So really the simplified version of this function is x plus 2 over x plus 3. And really, if you just have one factor, you don't technically need the parentheses, but I'll use them anyways. So let's first focus on what we know, the vertical asymptote. So I'm going to say this is to find the VA for vertical asymptote. We're going to set x plus 3 equal to 0 to get our vertical asymptote, x equals negative 3. Okay, and then the other part, we're not going to set the x minus 2 part to 0 because it's canceled out. So that is where we get our hole in the graph. And again, more on what that actually means once we get into the graphing part. So for that, I'm running out of room here. So I'm going to put h for hole and do x minus 2 equals 0 to get x equals 2. So we have a vertical asymptote at x equals negative 3 and a hole at x equals 2. Okay, and then our next example focuses more on the horizontal asymptote of the graph of the rational function. So this is a little bit more involved, and it has to do with, well, let's just look at the other page. So they all start with the degree of, the degree of, the degree of. All right, so we basically compare the degree of the numerator to the degree of the denominator first. So looking at our first example, it's second degree over first degree. So this would be an example where the degree of the numerator is greater than the degree of the denominator. So this would be our first case on the first page of your notes. Degree of a of x greater than degree of b of x, so there is no horizontal asymptote. So in this case, the answer would be none for part A. And again, that's because the degree of a of x was greater than the degree of b of x. Okay, and then in the next example, it says we have 2x plus 1 over 3x minus 2. So this would be the case where the degrees are equal. They're both first degree. So we're going to skip this one and go down to here. If the degree of a of x equals the degree of b of x, the horizontal asymptote is lead coefficient of a of x over lead coefficient of b of x. So in the case of this problem, our lead coefficient of a of x is 2. Our lead coefficient of b of x is 3. So, and it's in the form y equals because it's a horizontal line. So just y equals 2 over 3. Okay, so those are some initial things, and we are just going to kind of go through the next few examples as quickly as possible because we're not supposed to take a super long time on these notes that we give you guys. So I'm going to go ahead and fold what I've done so I can fit all of our examples. And basically, this is what you need to be able to do, and you're going to need to use the opposite side of the notes as well. All right, so we're going to graph 4x minus 12 over x minus 1. One thing you might do to start is go ahead and punch that into your graphing calculator. Clear out what we have there. And you do need to use parentheses there. So 4x minus 12 parentheses over parentheses x minus 1. And then just kind of get a visual of what it's going to look like. So usually that vertical line is going to be an asymptote. So we'll see if all that makes sense, and I'll come back to the table. So your domain kind of goes right along with any vertical asymptotes that you might have. They're going to look really similar. And remember, domain is where your denominator can't be 0, right? So if we think about that, x minus 1 equals 0. We get x equals 1. So we would say x cannot be 1. All right, and then so that is also our vertical asymptote, x equals 1. So as part of my graph, I'm going to go ahead and write that as a dotted line on my graph, x equals 1. So remember what an asymptote is. That's a line that my graph is going to forever get closer to, but never touch or never cross. Holes. So remember, to have holes is you have to have something that cancels out. In this case, we do not because 4x minus 12 and x minus 1 don't have any common factors. So this is not applicable here. So I'm just going to put none. Or you might put like 0 or something like that. Horizontal asymptote. So in this case, this is the case where the degree of a of x is equal to the degree of b of x, first degree over first degree. So just like our last example before this one, we're going to do the lead coefficient of a of x, which is 4, over the lead coefficient of b of x, which is 1. So y equals, because it's a horizontal line, 4 over 1, which just simplifies to y equals 4. So I'm going to go ahead and put that on my graph as well. Gonna look like this. And it is key, guys, that you use a dotted line when you're doing your asymptote so that we understand that this is not actually part of the function. These are just kind of our guidelines, basically, is how you can think of them. All right, so the x-intercept. The x-intercept is where y is equal to 0, okay? So here's an easy way to think about this. If I plug in 0 right here, what can I plug in for x to make that true? Okay, so really we're just looking at what can I plug in here to make this 0, because 0 over anything equals 0. So for this part, I'm just solving the equation. 0 equals 4x minus 12. And then just kind of talk you through that. Move the minus 12 over, we get 4x equals 12. Divide by 4, and then we get x equals 3. And remember, that's an x-intercept, so that would be the point 3 comma 0. And then we can always look back at our table and see if that all works out. Visually, you can see that it does look correct. Seems to pass through 3, 0, but just to be sure, we can just go right there to see that it does go through 3, 0. The y-intercept, so then we just kind of go back and we think that's where x equals 0. So if I plug in 0 there and 0 there, what I would end up with is negative 12 over negative 1. Which just equals 12. So it should also pass through 0 comma 12. So we can always come back here and see that that's true. Also, we can see that our asymptote or hole appears to be true. In this case, it's an asymptote. So that's really about all you need, are those kind of points right there, plus your asymptotes to be able to get a pretty good graph of it. So 3, 0, remember it goes through 3, 0. Also goes through 0, 12, which is going to be like right up there. Okay, I also, just because I am a little nitpicky, I like to put a few more points on there if I can, if they make sense. So just kind of go through it real quick. Negative 1, 8, we could use that to be helpful. Negative 1 goes to 8. Negative 3 goes to 6. Okay, but we get a pretty good idea of what that branch looks like. Now I'm going to go to the other side. It says 2 goes to negative 4. We already know 3 goes to 0 and 5 goes to 2. And you can just kind of pick and choose as you go, but that's going to give us a pretty good idea of our shape there. And I'm just going to try to trace that as a curve, and I'm going to be careful around my intercepts, not to cross them. And then we'll just do our best to kind of get the shape of the graph. Okay, so that's basically it. I think I'm going to stop the video there. The other two examples are worked out in full on the notes. And anyways, if this and the other videos that I've attached aren't enough, every other day, so in this case, you'll be watching this Wednesday. So Thursday, I'll have kind of office hours where you can hop on to one of these Zoom conferences and I can help you with homework problems. But if you don't need to attend that, if you can do it on your own, that is fine as well. And besides that, guys, good luck with your e-learning, and hopefully everything goes well for you. Have a nice day.